just going to go through, I'm going to talk through the solutions to these questions. I will upload and send to you the PDF version of this as well, so that you have that to look through, but I'm going to talk through it as well, just to make sure you follow what it is that I've done. So the first question starts off with: a manufacturer has a machine that fills bag with flour, so that the weight of flour in a bag is normally distributed. Label states that each bag should contain 1 kilogram of flour. The machine is set so the weight of flour in a bag has a mean of 1.04 and a standard deviation of 0.17. Find the proportion of bags that weigh less than the stated weight of 1 kilogram. So we have here a normal distribution. So X is normally distributed with a mean of 1.04 and a standard deviation of 0.17. I always find it helpful to write that part out at the beginning of the question. I don't know, it just helps me kind of organise my thought process. That would be my recommendation. Write it down before you start. Then we are trying to find the probability that X is less than 1. We're finding the proportion of bags that weigh less than the stated weight of 1 kilogram. To do that, and using the tables, we need to code our data so that we can use a standard normal distribution to be able to work out the probability. So to do that, we have to take our value of X and we have to subtract the mean and divide by the standard deviation, which is what I've done there, which gives me my value of Z, which is negative 0.23529. Our values of Z in the table are only to 2 decimal places, so we do need to round that. So we're finding 0.24 in the table. Find 0.24 in the table, and then because it's negative, we have to do 1 minus that probability. If we look at the probability distribution, oh, I did it, I drew it over there, hang on, never mind. We're trying to find minus 0.2 whatever, which would be down here somewhere, so that would be minus 0.2, etc. That would have the same probability as 0.2, but greater than. And when we're remember, when we're trying to find a probability that's greater than a specific value, we have to do 1 minus the probability that it's less than that value, which is what I've done here. So I found the probability that Z is less, that's right, probability that Z is less than 0.24, and then I've done 1 minus that value to get the probability, or the proportion of bags that weigh less than the stated weight would be 0.4052. All about using the symmetry of that distribution. For part B, the manufacturer wants to reduce the number of bags which contain less than the stated weight of 1 kilogram. So first she decides to change the mean and keep the standard deviation the same, so that only 5% of the bags filled are below the stated weight of 1 kilogram. Find the adjusted mean. So we have a new distribution, which I've called Y here, and we know that the probability that Y is less than 1 is equal to 0.05. Our standard deviation is still the same. I've just wrote that in a bracket over there. I need to find the value of Z. Again, I have to use a coded adjusted distribution so that I can use the tables of the standard normal distribution. So my value of Z, if I find 0.05 in the table, I can actually use the percentage point table, the little one. Sorry, you can probably hear me opening the textbook to the table so that I've got it in front of me. I can't find it, there it is. We can use the percentage point table because 0.05 is in there, but because the percentage point table finds us the probability that Y is greater than a certain value rather than less than, we have to make the answer value. So when we find that doesn't make sense. We have to make the answer negative. So when we find the value of 0.05 in the table, we get 1.6449. But because our question was less than, we have to then make that minus. So our Z is minus 1.6449. And then we have to undo the code to be able to find the median. So we have 1 minus our mean, which is still mu because we don't know it. So 1 minus mu over the standard deviation is still 0.7 is equal to this value of Z that we've just found in the table, kind of going backwards in the table. Rearrange that and work out what mu is, gives us 1.279633, etc., which rounds to 1.28, which is 3 significant figures. This here was just to demonstrate why I take the negative value of here. The percentage point table will give me the value, will give me this x value, which has the same probability as this negative x value due to the symmetry of the distribution. I hope that makes sense. And then part C, the manufacturer finds a lot of the bags are overflowing with flour when the mean is adjusted, so decides to adjust the standard deviation instead to make the machine more accurate. The machine is set back to the original mean of 1.04, and they want 1% of the bags to be under 1 kilogram. Find the adjusted standard deviation, given your answer to 3 significant figures. So I did that on the next page. I'm trying to find the probability that my distribution y is less than 1, and that has a probability of 0.01 because it said 1%. Again, use the percentage point table to find that, but again, our question is less than. The percentage point table will give you greater than, so we need to make it negative. So the percentage point table will give you 2.3263 as your value of Z. We need to make that negative because our question is less than. And then again, we use the code to reverse and work out what the standard deviation is. So our value that we had in the question, our y value is 1. We have to subtract the mean, which has reverted back to the original, which is 1.04. We divide that by the standard deviation, and it gives us a value of Z that is negative 2.3263. We reverse that, we rearrange, work it out, and we end up with sigma is equal to 0.01719, etc., which rounds to 0.0172 to 3 significant figures. I think the main point of confusion, I know for myself, is when to make something negative or when to subtract 1 from something. What I've now realized is if we are using the percentage point table, but our question is less than, we have to make our answer negative, because the percentage point table gives you a value of Z that is greater than the distribution. And then as we go through, we'll have a look at when we have to do the 1 minus part, because it comes up a lot. And there's very few questions where you don't have to subtract your probability from 1 out of the exam questions that we've chosen. I don't know if that's coincidence or if that's just typical of, I would imagine it's just typical of the exams, because these are like 4 years in a row, I think. Questions from 4 different years, but all one after the other. And most of them you have to do 1 minus the probability rather than just picking the probability straight out of the table. Anyway, this question was really nice, actually. The random variable y is normally distributed with mean mu and standard deviation sigma. You don't know the values of them. Given that the probability that y is less than 17 is equal to 0.6, find the probability that y is greater than 17. This is where you have to use your 1 minus trick, because if the probability, there's my distribution, if the probability that it's less than 17 is 0.6, then the probability that it's greater than 17 is this side of the distribution. and the area under the entire distribution adds up to 1. So we have to do 1 minus 0.6 is 0.4 for the first question. This second part, the probability that y is between the mean and 17, here we have to use the fact that the mean is like in the middle. It's half of the distribution. So if we think of the distribution visually, our mean is here, so mu's here, and 17's up there. So to find this area, we need the probability that y is less than 17, which would be all of this green part, and we need to subtract the probability that y is less than mu, less than the mean, which would be this part. This orange part has a probability of 0.5 because it is half of the distribution, which is why I did 0.6, which was the probability that y is less than 17, which we were given in the question, subtract 0.5, which gives us a probability of 0.1. So this squiggly part here that I scribbled on has a probability of 0.1. And then the last one is find the probability that y is less than the mean given that y is less than 17. To do that, the probability that y is less than 17 is 0.6, as we already said, and the probability that y is less than the mean is 0.5, again, as we've already said. If it's a given question, just like any other time in probability, I don't know if you can hear that airplane, it's very loud. I lost my train of thought. Any other probability question, any other given question, find the probability of x given y. We take we do the probability that y is less than the mean out of the probability that y is less than 17. So 0.5 divided by 0.6 gives us 0.83 recurring, or just 0.833 if we round it to 3 significant figures. And that's that question done. It's not very many marks, it's only 5, but I think those are quite, if you had a question like that in a real exam, they would be 5 pretty straightforward marks to grab. Right, the next question. One event at Pentos Sports Day is throwing a tennis ball. Exciting. The distance a child throws a tennis ball is modelled by normal distribution, mean 32, standard deviation 12. Any child who throws the tennis ball more than 50 metres is awarded a gold certificate. Show that to 3 significant figures, 6.68% of children are awarded a gold certificate. So this is what I'm doing here. Again, I've wrote out the distribution. Again, it helps me kind of start the question. It's not really any more useful than picking it out of the question, but it means it's there, it's easier to see, I guess. And we are trying to find the probability that x is greater than 50. Again, we have to code our data because we can only read the standard normal distribution from the tables. So we subtract the mean, divide by the standard deviation, means we are finding in the table the probability that z, our standard normal distribution, is greater than 1.5. Again, our normal, the actual table, not the percentage point table, the normal table is all less than. Our question is greater than, which is why we then have to do 1 minus that to find the probability. So we need to actually find the probability that 1 minus, we actually have to calculate, that's what I'm trying to say. We actually need to calculate 1 minus the probability that z is less than 1.5, which is what we can read from the table. When we find it in the table, that gives us 0.9332. 1 minus that gives us 0.0668, which is 6.68% when you change that decimal into a percentage by multiplying it by 100. So we have shown that 6.68% of children get that gold certificate. Part B, a silver certificate is awarded to any child who throws the tennis ball more than d meters but less than 50. Given that 19.1% of the children are awarded a certificate, find the value of D. So we're finding the probability that X is between D and 50. We obviously need to code that and change it to use the standard normal distribution. So I changed my value to call it E, just so I didn't get confused. But I'm finding the probability that Z is between E and 1.5. This 1.5 I just plucked straight out of the question before. I'd already worked out that value of Z. To do that, when you have a double inequality, we have to do the probability that Z is less than 1.5 minus the probability that Z is less than E. Just like we looked at kind of here, when you've got that double inequality, we do the probability that the bigger one minus the probability of the smaller one. So the probability, we know that it has to equal 0.191, as they've said in the question. The percentage is 19.1%, so that's 0.191 as a decimal. We know the probability for this, we've worked it out already, is 0.9332. I've already done some rearranging here, so I've added the probability that Z is less than E over here, subtracted the 0.91. So when I do 0.9332 minus 0.191, that gives me the probability that Z is less than E, which is 0.7422. And that is not my answer yet. I then need to use that to find what E actually is. So using the tables backwards, I need to find 0.7422 in the probability column and read off what E is, which is 0.65. E is coded so that it's in standard normal distribution. So I need to uncode it to get back and actually find out what D, the real life distance, actually is. So I would have taken my D number, I've minused the mean and divided by the standard deviation to get 0.65. When I rearrange that and work it out, I get D is equal to 39.8. At least I think that's a 9. I can't really read my own writing. It's a 9. The very last question, I'm a little bit confused why it's worth 3 marks. It's very straightforward. To find the probability that 3 children are selected at random from those who take part in the throwing a tennis ball event. Find the probability that one of them is awarded a gold certificate and 2 of them are awarded silver certificates. Give your answer to 3 significant figures. If those children were named and it was find out the probability that Tom gets gold and Taylor and Harry get Taylor and Harry get silver. I've been listening to Taylor Swift and One Direction, which is why Taylor came into my head, and Harry Styles. But anyway, here we go. So Tom gets gold, Taylor and Harry get silver. If it was work it out and those specific children are given specific medals, then we would just do that once. We would do 0.0668, that's the probability of winning a gold medal, and multiplied by 0.191, and then another multiplied by 0.191 for both Harry and Taylor to get their silver medals. However, we haven't been told exactly who's getting what. We've just been said there's 3 children, they're each going to win a medal. What's the probability that one of them's gold and 2 of them silver? So we have to also multiply it by 3 to take into account that any one of them could get that gold medal. We could have Tom's gold, Taylor and Harry are silver. We could have Harry's gold and Taylor and Tom are silver. And you get my drift. So we have to remember to times it by 3. And when you work that out, you get 0.0073, two significant figures. I say I'm not sure why I chose 2 significant figures, because that's what it says in the question. And then that's that question done. I hope you're starting to see that most of the questions are very similar, or at least they have very similar elements. One once you've done a few of them, you do start to kind of get into a routine of it, and you kind of learn the method that you have to do. It is very, very similar each time, which is helpful because it is quite a confusing topic. The next question, we have the birth weights of a particular breed of kitten are assumed to be normally distributed with a mean 99 and a standard deviation of 3.6. Find the probability that W is greater than 92. Again, I've wrote out my distribution here, and now I'm finding the probability that W is greater than 92. I need to code it to put it into the standard normal distribution Z. So I subtract the mean and divide by standard deviation. Means I'm trying to find the probability that Z is greater than minus 1.94. This is the same as finding the probability that Z is less than 1.94. So if I have my distribution, the probability at 1.94 greater than is this part of the graph up here, which would be the same as doing the probability of 1.94 less than 1.94. So both of those two things will give us the same probability. This one we can't find in any table, so which is why we have changed it to this, because that we can find in the big standard distribution table. So when we go through and we find the value, we get the probability is 0.9738. That's the first question. That's 3 marks. Again, for once you kind of spot the patterns, for very little work really, that's 3 marks. This part B was interesting. I've done it a very different way to how the mark scheme did it. But I got there in the end. Find to 1 decimal place the value of K so that the probability that W is less than K is equal to 3 lots of the probability that W is greater than K. What I did was use the fact that the probability that W is greater than K is the same as 1 minus the probability that W is less than K. So then I just have less than K on both sides of the equation. Remembering that I have 3 lots of it, so I expanded that bracket out. So I have the probability that W is less than K is equal to 3 minus 3 lots of the probability that W is less than K. I added the 3 probabilities of whatever over to the other side, so I get 4 lots of the probability that W is less than K, and then I divided through by 4, giving me the probability that W is less than K is equal to 3/4. So if that's equal to 3/4, then the other probability is equal to 1/4, because that the probability that W is less than K is 3 times the probability that W is greater than K. I then need to find a value of Z in order to kind of uncode it and find what K is. So I use the table, the big table. I go through and find 0.75 and read off my value of Z. Now I think, unless I'm very much mistaken, let me just check on my table. I don't think 0.75 exactly was in the table, is what I'm thinking, but I can't remember. 0.75, no it's not. Okay, so the 2 values that are closest are 0.7486 and 0.7517. 0.7486 is closer to 0.75, so I take this value of Z, 0.67. Yeah, we did mention that in the lessons, but watch out for that. Sometimes the probability isn't in the table exactly, so take the one that is closest to it. And we are talking like a 0.0001 closer than the other option, but it's closer all the same, so we use that one. Once we have our value of Z, we can pop the code and uncode it. So we know that we took K and subtracted the mean, divided by standard deviation, and that gave us a value of Z that was 0.67. rearrange, solve, find what k is, and you get k is 101.4 to 1 decimal place, which is what it asked for, 1 decimal place. Write down the name given to the value of k. So because the probability of it was 0.75, that means k is 0.75% of the way through our distribution, through the data. So k is actually the upper quartile. That's only worth 1 mark, so don't worry if you couldn't spot that on your own. But that's quite a nice little way of getting quartiles into an otherwise unrelated question. And then the last part, for a different breed of kitten, the birth weights are assumed to be normally distributed with a mean of 120. Given that the 20th percentile is 116, find the standard deviation. Again, I wrote out the distribution just because it helps me. I know that the probability that x is less than 116 is equal to 0.2. I have to go backwards in the table to work that out. I can use the percentage point table, but again, because the percentage point table gives me all of the probabilities greater than, and my probability is less than, I need to take the negative value. So I find 0.2 in the table, and I read off the value of 0.8416, but I make mine negative because my probability is less than instead of greater than. And again, I have to use the code to try and work out what the standard deviation is. So my value of x was 116. I subtracted the mean, 120, divided by standard deviation, and that gave me a z value of negative 0.8416. Rearrange that, solve it, find what sigma is, gives me the standard deviation is 4.75 to 3 significant figures. And that's it. Yeah, again, I mean, with the exception of those middle 2 parts, B and C, B was quite unusual. That's the only question I've seen like that. But in terms of like trying to find a standard deviation or a mean, finding a basic probability, usually one where you have to do 1 minus something, it's all pretty standard and it's all very similar no matter the question. There's nothing like weird and wacky they can ask you about this. It's very much a standard type of question. They can throw the odd thing in there like this 3p and p thing, but most of the questions have to follow a kind of standard form because there's not an awful lot they can ask you that deviates away from that. Are we nearly there? I think this is the last one. It is the last one. I feel like I've talked for an hour. I know it hasn't been, but I feel like I have. Right, first question is the first part of that question is really easy. Police measure the speed of cars passing a particular spot on a motorway. The random variable x is the speed of the car. X is modelled normal distribution with a mean of 55 miles per hour. Draw a sketch to illustrate the distribution of x. Label the mean on your sketch. There's my sketch. There's my mean is 55. As long as you get the basic shape and 55 is labelled on there, you don't actually need the y-axis. It's enough to just do this and just make sure 55 is labelled there. And that is 2 marks. Done. Really, really straightforward. And then part B kind of goes into start using it. So the speed limit on the motorway is 70 miles per hour. Car drivers can choose to travel faster than the speed limit, but they risk being caught by the police. That's an interesting way of describing speeding on a motorway, but here we are. The distribution of x has a standard deviation of 20 miles per hour. Find the percentage of cars that are traveling faster than the speed limit. So there's my distribution. Oh, I didn't realize to let the pen on. X is normally distributed with a mean of 55, a standard deviation of 20. I'm trying to find the probability that x is greater than 70. I need to code it, put it into the standard normal distribution. So I minus the mean, divide by standard deviation, means I'm trying to find the probability that z, my standard normal distribution, is greater than 0.75. Again, my table doesn't give me greater than, it gives me less than, so I have to do 1 minus 0.7734, which is the probability that z is less than 0.75. I find 0.75 in the table and I read off this value. And then when I do the 1 minus that, I get 0.2266. So that is the, oh, it says percentage, doesn't it? I haven't changed it to a percentage. I didn't realise I hadn't done that. So the answer actually is 22.66% because it asked me to change it to a percentage. Find the percentage of cars. The fastest 1% of car drivers will be banned from driving. Show that the lowest speed, correct to 3 significant figures, for a car driver to be banned is 102 miles per hour. Show you're working clearly. So, I'll do this on the next slide. Probability that X is greater than, I used F for the fastest, is equal to 0.01 because it's 1%. My value of Z is 2.326. I can literally read that straight off the percentage point table because my probability is greater than that percentage, that probability is in the table, so I can use that and just read off that. Z has to be 2.3263. Again, I have to uncode it to find what F is, what my fastest speed is. So I do F minus 55 over 20, so that's F minus the mean over the standard deviation, is equal to 2.3263. Rearrange it, solve it, find that F is 101.526, which to 3 significant figures is 102, which is what they asked for. So I ticked it because I got it right. And then the last part, I liked this question. Now that I'm confident and enjoying the normal distribution, I liked this question. Car drivers will be just given a caution if they are traveling at a speed m, such that the probability that X is between 70 and m is 0.1315. Find the value of m. So to work out the probability that X is between 70 and m, I would take the probability that X is less than m and minus the probability that X is less than 70, as we've seen in a couple of the previous questions. This makes it nice and easy because I don't have to do any one minusing or change my answers to negatives and things because they're both less than questions, less than probabilities. They're easy to read from the table. I do need to code it, however, 70 is the only thing I can code at this point, and I've already done that in one of the previous questions. I did that here. I coded 70 and it became 0.75. So I'm trying to find the probability that Z is less than, I've changed my M to Z again so I don't get confused. So the probability that Z is less than little z minus the probability that Z is less than 1.5, and that gives us an answer of 0.1315 because we've been given that in the question. The probability that Z is less than 1.5 is 0.7734, and then I rearrange it to get probability that Z is less than little z is 0.9049. Now I have to use the tables and go backwards to find out what the value of little z actually is. So I find 0.9049 in the table and read off my value of z, which becomes 1.31. And then using the code, if I take m and subtract the mean, divide by standard deviation, I get a value of z, which is 1.31. I solve that to find what m is, and m is 81.2. I didn't have to round it, it was just 81.2. And that's the answer, that's it done. That is all of those 6 questions on normal distribution complete. Yeah, so I think with a bit of practice and with some explanations from me that actually make sense, I don't think it's actually that bad. I know I was very negative about it last week and the week before. Not last week was the holiday, before the break. I was very negative about it. I'm feeling like it's actually not as bad as I've made out. I think I had a bad day rather than normal distribution's bad. I think I've took my frustration out on normal distribution, which isn't nice. I shouldn't do that. I shouldn't blame normal distribution for me having a bad day. But anyway, I don't think it's as bad as I thought it was. Like I say, a lot of the questions kind of follow the same kind of format. You have to do the same type of thing. If you can remember, I think that definitely helps, is starting to remember and pick up and spot quite quickly where you have to do 1 minus something, and where you have to change a positive value to a negative value and things like that. If you can spot that a bit quicker without having to, like I had to do in a lot of these questions, without having to go back to the actual distribution and look at the symmetry and kind of work it out the long way. If you can start spotting that a bit quicker, then it all becomes a lot easier. And that only comes with practice, which I know is the boring teacher answer, but it is very true. The more you practice this, the more you'll kind of pick up those little points and just remember to do them, rather than having to really think about where it comes from. Yeah, so I hope that helped. If you have stuck with me to the end of this video, thank you. Well done. Have a lovely day, and I hope this helped. Bye.